Hello, my name is Clint Johnson, and today I'll be talking to you about orbitals. So, orbitals, what are they? Well, the definition is the area in which the highest probability of the electron being by the atom. So, what it basically is where is the atom, or where is the electron compared to the atom? Now, there's no 100% determinable way to know or to predict where the electron is, but what we can do is we can predict the probability. So let's pretend this is our nucleus. And just keep in mind that for a neutral atom, the number of protons will be the same as the number of electrons, but that's not really relevant information right now. Just keep that in mind. But anyways, so here's your nucleus. Now, for the nearest orbital, which is the 1s orbital, we'll get back to that later. Just keep in mind that it's the closest one to the proton, or I mean to the nucleus. So for that orbital, it's going to want to be as close to the nucleus as possible because that Coulombic attraction is the highest. So this density of plots represents the probability of the electron being. So let's say it's the thickest in here. It's really thick in here. I'm just going to scribble it in to represent the thickness. And then let's say it's like a 90% chance that it'll be in here. Well, that's only a percent chance. It could also be over here. It could also be over here. It could also be in here, out here, but that's for less of the time. It's most likely going to spend the majority of its time right in here, right close to the nucleus. But it could also be out here, out here, out here. Just keep that in mind. So, another thing about orbitals is one orbital can only hold 2 electrons. Now, you're thinking, well, can't an atom have more than 2 electrons? Yeah. The answer to that is yes, it can. Now, this diagram represents how many orbitals there are per sublevel and per energy level. So for the first energy level, it's called the 1s, and the exponent here just represents the number of electrons that it can hold. And just keep in mind that an orbital can only hold 2. So each orbital in here will be 2. But anyways, the first energy level 1, its only sublevel is going to be this 1s sublevel, which can only hold 2 electrons. That's why the innermost shell can only hold 2 electrons. Remember, we were talking about this earlier. If we're gonna draw an atom, let's make this its nucleus. Well, this is gonna be its shell. Then we got these 2 electrons, and they're gonna spend most of their time within this shell. The shell just represents the probability, the likelihood, I guess the greatest probability, where it will be spending most of its time will be inside that shell, but this electron could also be out here, but it's going to spend most of its time in here. So anyways, that's the first energy level. Well, energy level 2 has two sublevels. It has the 2s, and it also has the 2p. Now, every energy level has to start off with an s. Then its next sublevel, if it has one, will be the P. After the P, it's going to be the D. After the D, it's going to be the F. Now, as the energy levels get greater, so does the sublevels, or so does the orbitals. So is the number of orbitals within the sublevel. So the S only has 1 orbital. Well, the P has 3 orbitals. The D has 5, and the F has 7. Increases by 2 every time. Now, how you get the number of electrons is you add up, or the number of total possible electrons is you add up the orbitals. So we got 1, 2, 3, 4 orbitals right there. Now, remember, one orbital can hold 2 electrons, right? So you multiply 4 by 2, and you get 8. So this energy level 2, can hold 8 electrons. Now for the next one, we got these 8 here with the S and the P, but it also has this D. The D sublevel has 1, 2, 3, 4, 5 sublevels, or orbitals, excuse me. Now an orbital can hold 2 electrons. So again, you multiply 5 by 2, you get 10. Well, 10 plus 6 plus 2 equals 18. Yep, you got your 2, 4, 6, 8, 10, 12, 14, 16, 18 electrons. Now, for this energy level 4, you have your 18, this 18 electrons, and then you also have 2, 4, 6, 8, 10, 12, 14. So you add those together, and you get a grand total of 32. I think it should be. Nope, 34 electrons. No, 32. Excuse me. Here, let me do the math here. Just make sure. Yep, it's going to be 32. So this sublevel, or this energy level 4, is going to be hold a maximum of that number of electrons, 34. Now, it's enough about that. Let's start drawing some diagrams. So let's say my electron configuration is going to be 1s2, 2s2, 2p6, 3s2, 3p3, let's just say. So we got to cover our 1s orbitals first. So this is going to be our nucleus. Then you got that 1s2 right there. So I've filled in, this is the 1s1 electron, the 1s2 electron, and again, it's not definitively going to stay on this line for the entirety of its life. The electrons are going to float around in here and here. They're going to be closest to the nucleus as possible, but they're going to be out here, but probably not for most of the time. We've already covered that. Now let's move on. The 2s2. Well, for the second energy level, now remember our diagram here. It has 2 sublevels. We got the S and the P. So we got to do the S first. 1, 2, that's 1 orbital. 1 completed orbital, I should say. And then for the P, 1, 2, 3, 4, 5, and 6. So all these now are completed orbitals, and we have remaining electrons here, which means we have to go up another energy level. So there's your energy level. So 3s2, 1, 2, and then we got 1, 2, 3. So here's 1 completed orbital. And remember, we have 3 sublevels in the energy level, or in the third energy level, for a grand total of 1, 2, 3, 4, 5, 6, 7, 8, 9 orbitals, and this is the only complete orbital we got. And since we've used up all those electrons, we stay at this level. We do not need to go up another level because we've completed this valence, or with this valence shell with all of its electrons. So yep, that's the basis of electrons. Now one more thing to remember. This line here kind of depicts like the probability, or the greatest probability of where it's going to be, the greatest time spent, if you will. So this is the electrons on this. I'm going to be in here and here In here, what you might find one floating in here, all the way in there. You might find one floating way out here, but it's going to be spending its time on this circle for the most part. That goes for all of them. So thank you for watching. And just remember about orbitals, they can only hold 2 electrons apiece, but as you move up energy levels and sublevels, the orbitals increase, but each orbital can only hold 2. And the orbital is not a definitive way to predict where the electrons will be. There's no way to prove that yet in science, but it's going to be the how we can. It's just the highest probability of where it's going to spend most of its time. Thank you.